Hello everyone. Today we've got our video on chapter 19, which is the first lesson on testing hypotheses. For our purposes, it'll be for a single proportion. The same idea is going to be extended throughout the entire semester. So getting a good grasp of what it means to test a hypothesis now is going to help you in the future. Okay, so to start off, we have to talk about what the hypotheses are when it comes to a hypothesis test. And with every hypothesis test, we start with an initial claim, and this is what we refer to as our null hypothesis, okay? We denote it with H sub 0, or that just stands for null hypothesis. And the null hypothesis, it is what provides a claim of what our population parameter is, okay? So for example, if we're talking about the student body at Fargo North High School, and we believe that 50% of students are female, well, we would start with the claim that P is equal to 0.5. That's what we're claiming is true to begin with. So when it comes to the null hypothesis, you always state that the parameter is equal to some value, okay? So like I said, for our purposes, it could be P equals 0.5, all right? Another example, if we had a null hypothesis of P equals 0.3, where P is equal to the true proportion of people infected by a disease, okay? So key thing here is that when it comes to the null hypothesis, we always have some sort of equal sign that we're claiming that our parameter is equal to. So with the null hypothesis, we have equality. We're claiming that our parameter is equal to something. Then we have what's called the alternate or alternative hypothesis, and that's what we denote with H sub A, the A standing for alternative hypothesis. And this is where we outline what our parameter values could be if our null hypothesis is not true, okay? So for example, if we hope to find evidence that a new medication decreases the percentage of infection, then our alternate hypothesis is that P is less than that current percent. In other words, we could say our alternate hypothesis would be P less than 0.3, okay? So again, we're starting with the claim that P is equal to 0.3, but we also want to know if there's evidence that that is not true, what values of P could P take on? And we're saying here P would be less than 0.3 or 30%. So when it comes to a hypothesis test, we want to compare what we observe in a random sample to what our original claim was in the null hypothesis. And this allows us to determine how likely what we observed is if we assume that null hypothesis is true. So for example, if we're talking back in our medicine or disease example, we are claiming in our null hypothesis that the percentage is 0.3 or 30%, but maybe we take a random sample of say 100 people and we find that that sample proportion, so within those 100 people, 21% of them have the disease, okay? And what we want to know is how likely is it to occur that if the true proportion really is 30%, to find a sample where that is only 21%. Okay, so if that probability is really, really low, we have reason to believe that, hey, maybe that P isn't actually equal to 30%. It might actually be less than 30%. Okay, so again, we're starting with our original claim. We're comparing that claim to what we observe in our sample. And then we want to know, is that far enough away from what we assume to be true in the beginning to lead us to believe that maybe that isn't true after all? So if you're a little tied up on like the numbers behind a hypothesis test, we can kind of think of this in terms of a court case in a standard criminal court case or any sort of court case, I guess. So in a court case, what we do is we always assume that somebody is innocent, okay? We never go into a trial saying, oh, this guy's guilty, we just got to prove him innocent now. We always say we're going to assume that he's innocent. And what we do in a court case is we retain that innocence hypothesis until we have enough evidence to suggest otherwise. And if we have enough evidence, then and only then can we reject the hypothesis of innocence and declare that somebody is guilty, okay? So again, throughout an entire hypothesis test, you're going to do that same thing. You're going to assume that null hypothesis is true until you have evidence to say it is not true. So as I said, in a hypothesis test, You start by assuming that null hypothesis is true. Then we gather data and decide if that aligns with our hypothesis. If it does, then we would say we fail to reject the null, meaning there's no evidence that the null is not true. But if that data does not align with what our null hypothesis was, then we can reject the null hypothesis. And that just means that whatever we had in our alternate hypothesis, there is evidence that that would be true. So when it comes to determining is there evidence that our null could be true, could be not be true, it all comes down to what we call our p-value, okay? And a p-value is simply a conditional probability. So the p-value, which is different than our p, our parameter, also different than our p-hat, so there's a lot of letter p's coming around. Our p-value, it is the probability of what we observe happening, assuming that our null hypothesis is true, okay? So if we assume that null is true, it is the likelihood of observing that p-hat value given that the null is true, okay? And if that p-value or that probability is low enough, and we'll explain what low enough is here in a moment, then we can say we reject the null hypothesis, okay? In other words, there is evidence that the alternate hypothesis is true. So one of the easiest ways to learn and remember how to conclude in a hypothesis test is this phrase here. It's kind of got like not a rhyme to it. Well, it does rhyme. Anyway, if the p-value is low, reject the null. So if that p-value is low enough, in fact, we're going to define what low enough means in a moment, we are then going to reject the null. So if the p-value is low, we reject that null. So a couple of things when it comes to the p-value. First off, and this is the most common mistake I see, we never accept the alternate hypothesis, okay? There are only two possible outcomes when it comes to a hypothesis test. So if our p-value is big enough or it's above what our threshold is, all we say is that we fail to reject the null. And if the p-value is low or below our threshold, we would say we reject the null hypothesis. So you always want to state your conclusion in terms of the null. Either we fail to reject it or we reject it. Now, with a hypothesis test, similar to with the confidence interval where we had panic, for a hypothesis test, we have a phantoms. So this is going to be a really good tool so you can remember each of the steps in a hypothesis test. And luckily, many of the letters that we had for a confidence interval will transfer over to a hypothesis test. So not all of this is going to be brand new to you guys. P, again, stands for defining what your parameter is. So what are we trying to estimate? Again, for our purposes right now, it is just P equals the true proportion of, and then whatever you're trying to estimate, okay? Then H, that stands for declaring your hypotheses. So it's really simple. You just say our null hypothesis is, say, P equals 0.3. Our alternate is that P is less than 0.3, or whatever your hypotheses have to be, okay? Your assumptions, that is what A stands for, and luckily they are almost exactly the same as what we had before. I'm going to show you in class, there's one minor difference, but for the most part, they're exactly the same. N stands for naming our test. So before it was naming our interval, here we're going to name our test. It is just a one proportion Z test. One proportion because we're dealing with one proportion. And Z test, Z refers to our test statistic, which is what T stands for. And I will show you how to do that on your calculator. So that's what T is. O stands for obtain a p-value. And remember, this is what's going to determine do we reject the null or do we fail to reject the null? Again, calculator is going to help you out a lot on that one. M, that stands for make a decision. So if you talk about your p-value, is that low enough? Is it not low enough? That's where we make the decision to either reject or fail to reject the null. And then finally, we want to state our conclusion in the context of the problem. So there is evidence of the alternate or there's not evidence of the alternate. So this is just one quick note here. I don't stress too much about, so I mentioned in the previous one on phantoms, there's T, that stands for test statistic. There is a way that we're capable of calculating that by hand. The AP exam has slowly shifted away from that expectation, but I will show you guys in class how to find that test statistic. Luckily, it's super easy. It's just Z equals our p hat value minus our null hypothesis value for P. So if we assume that P is equal to 0.3, we just subtract 0.3 and then divide by the standard deviation of P hat. So again, not going to stress too much about this, but just know that it might pop up on the AP exam, and I'll show you guys on the formula sheet where that's located. Now, another note, when it comes to checking if the p-value is too low, so if the p-value is low, reject the null, or don't reject the null, we usually compare it to an alpha level of 0.05. So in other words, if your p-value is less than 0.05, then we're going to reject the null. But if it would be greater than 0.05, we're going to fail to reject the null. Sometimes in a problem, I will say test at an alpha level of 0.01 or 0.10. But if that isn't given to you, just assume that that p-value is, or that, excuse me, that alpha is 0.05. Couple of other notes, when it comes to the alternative hypothesis, really there are three options. Two of these are what we call a one-sided test. The other is called a two-sided or two-tailed test. If we have that our parameter, so P is less than a value, or that P is greater than a value, that's what we refer to as a one-tailed test. Whereas if we say P is not equal to a number, that's called a two-tailed test. Whereas in the null hypothesis, we always have P is equal to some value. So in your alternative hypothesis, you're going to have some sort of inequality, whether it's less than, greater than, or just not equal to. And then in our null hypothesis, we'll always have P equals some value. And the reason we call, if we say P is not equal to a value, the reason we call that a two-sided alternative or two-sided two-tailed test is because we're equally interested in deviations on either side of the null hypothesis. So we want to know, is it greater than or is it less than? We're not just interested in one direction. And we will compare that to a one-sided alternative where we have just less than or just greater than. In that case, we're only interested in one side of our normal curve, whether we're going to reject or not. So as we come to class, I promise I will walk you through how to do one of these. You're going to see a lot of similarities to a confidence interval. The one tricky part, I think, is going to be stating the conclusion correctly. With that, either you reject or fail to reject the null. You never really accept anything when it comes to a hypothesis test.